We have Tipton Cole speaking, and he's actually one of our sponsors at PyTexas, so thanks for sponsoring.
I'm told, for what it's worth, that the selection of speakers was not based on... All right. Here, I turn on my laser pointer. Make sure that, oh boy, that's great. That's a great little dot. Okay.
Can you use your mouse?
I'm sorry. I have a MacBook Pro, which means that my life consists of dongles. Now I have no chance of getting this talk done on time. My name is Tipton Cole. My day job, as it were, is I work as an expert in software litigation, mostly patent suits involving software. And I can tell you from experience that an expert is somebody who has done it more times than you have, and usually that means once. Talk is entitled Epigrammatic Python. This told me to be sure to test my laser pointer. When I was preparing this talk the first time, my wife was out running errands, and I called her and asked her if she could get me a laser pointer at the Office Depot while she was out. She searched the entire store, unable to find one, and finally flagged down a clerk who told her that the most likely spot for picking up a laser pointer was PetSmart. It turns out cats like lasers. And sure enough, I went and searched on Amazon, and you'll see that the first completion of the laser pointer for any purpose whatsoever is for cats. All right, epigrams. The definition of an epigram is a pithy saying or remark expressing an idea in a clever or amusing way. I've always been fond of the epigram that the race is not always to the swift, nor the battle to the strong, but that's the way to bet. Tiger Woods won the Masters Championship today. So an epigram is pithy, clever, amusing, and true-ish. Purpose of the epigrams that I'll present today is to help guide us in the development of computer software and to help us build better systems. But many of the humorous observations are not all that helpful. They are situationally wrong, they are wrong in scope, or sometimes they're just plain wrong. One of my favorites from the early 70s is from Roy Ash at Litton Industries, who said, "Our motto is, when in doubt, do the right thing." I've always taken a lot of confidence from that saying. I like Fred Brooks. When you talk about software, I like Fred Brooks. Programming. The programmer, he says, is like the poet who worked only slightly removed from pure thought stuff. And he also described it as few media of creation are so flexible, so easily polished, so easy to rework, so readily capable of realizing grand conceptual structures. Now, there are people who disagree with that, and I picked up a bunch of sayings associated with programming. No code is faster than no code. Deleted code is debugged code. I hate code. I want as little as possible in our product. And when in doubt, leave it out. So, the best code, they say, is no code. The next best code is less code. So what explains this attitude that we all seem to have? You heard it expressed over the last couple of days. And one of the things that I found most reassuring in the last couple of days of listening to talks here and you will see it later in this one, is that many of the themes, many of the items that I address there have already been addressed by the previous speakers. That is, there is a commonality in all of these discussions. So how can code be bad? That's what we program with. That's what we do. So why are those who are responsible for delivering, maintaining, working software, why are they so skittish? Why are they so uncertain? What is it about computer code that makes us so reticent about what we're doing? Why are the communities that plan, develop, and rely on computer software so conservative? It's because the code is brittle. Although we have this plastic medium, it's so tempting to overwork it. We want to add a feature, we want it to go faster, we want to tie into a new API, we want to put it on the cloud, and we know we can make it work. We have a lifetime of experience that says everything can work, but the code is brittle. This is the first launch of the Ariane rocket for the European Space Agency. The reason it blew up was they took a fully tested module and moved it into another context where one of the values, 64-bit values, was coerced into a 16-bit integer. And that cost them probably not $500 million, but it cost them a lot. So, our medium is perfectly plastic but brittle. The process and product seem to be unavoidably flawed. So, other epigrams associated with our work. Any non-trivial program, we're told, contains at least one bug. And this is my favorite. Software being done is like your lawn being mowed. If debugging is the process of removing software bugs, then programming must be the process of putting them in. So Python, I think, gets a lot of our concerns, a lot of our worries, and readdresses it in a good way. We've heard about the Zen of Python earlier today. This is my favorite part. Explicit is better than implicit. Import this if you want to see it on your REPL. Writing software as if we were the only person that ever has to comprehend it is one of the biggest mistakes and false assumptions we can make. There's an easy estimate from Robert Martin that we read 10 times more software than we write. That number is probably very conservative. Don't complain about bad code, rewrite it. When you feel the need to write a comment, first try to refactor the code. Now, I think we heard that earlier today. Somebody who said, don't write comments, write better code. Well, it's not always available to us. One of the things about PEP 20 that caught me when I was preparing this talk was the abstract, which explains exactly what it's directed at. That is, Tim Peters is talking about the guiding principles for Python's design, not necessarily all of the applications that we write. When you look back through the Zen of Python in its completeness or near completeness, look at it as the guidance for the development of a computer language, not necessarily for all the uses of that computer language. The explicit context for PEP 20 is language design, not applications programming. Now, just a little bit of an editorial comment here. How is Python doing with their explicit is better than implicit? Recently, in the last couple of releases of Python, we've had two examples, something I like. I'm very fond of the reimplementation of the data dictionaries. I'm not as fond of PEP 572. And the way that I would characterize them is that the dictionary rewrite is a sort of semantic sugar. The assignment expressions is more of a syntactic sugar. And my concern is that it begins to feel a little bit more like Perl. And those of us who worked with Perl in the 80s and in the early 90s, I left. PEP 20 probably deserves its own talk. I'll try to work on it, prosaic Python. But I think that explicit is better than implicit is very nearly universally applicable. That is, the context in which it was offered was for the design of a language. I think it's entirely useful in the... So, epigrams come down on both sides of many issues. So if you've ever heard the expression penny wise, pound foolish, you probably also heard the expression if you take care of the pennies, the pounds take care of themselves. And so my question for you is, which one do you apply? When you're at the automobile dealership or somebody's pitching you a condo in Vail, which of these do you apply? And the answer is, just do the right thing. In the programming world, I picked for this talk a couple of useful rules of thumb for programming. And we've heard some of both of these during the discussions earlier today and yesterday. The first is the don't repeat yourself or DRY principle, also known as once and only once. This is from Andy Hunter and Dave Thomas in The Pragmatic Programmer. The description that I think is particularly apt is when you find yourself writing code that is similar or equal to something you've written before, take a moment to think about what you're doing and don't repeat yourself. On the other side of that coin is the wrong abstraction from Sandy Metz. Some of you may have seen it before. I think Sandy works mostly in the Ruby world. And if you haven't seen it, I recommend that you look up her blog post called The Wrong Abstraction. And she expresses it multiple times, saying that duplication is far cheaper than the wrong abstraction, or that one should prefer duplication over the wrong abstraction. If we go back to Chris Peters, who, by the way, is not Tim Peters, it's a different Peters. If you go back to Chris Peters' statement, he's saying code that's similar or equal to something you've written. Similar is not the same thing as the same. And this is one of the points that Sandy Metz makes. Using DRY couples the components from which you extracted the code. So when you go to the process of pulling code out of two other processes and drying it out, those two processes are now linked to one another through the consolidated code. And we saw it today talking about doing testing. When you dry out those tests, now your tests are codependent. And generally speaking, for unit tests, you want them to be independent. So there are costs associated with it. DRY, it turns out, is rooted in what is known as the fundamental theorem of software engineering. This is from a guy named D.J. Wheeler. Wheeler was, among other things, credited with the development or creation of the subroutine, along with a couple of other guys in the 50s. Wheeler, it turns out, actually had a PhD in computer science in 1951. I didn't know such a thing was offered in 1951. Anyway, his statement is that all problems in computer science can be solved by another level of indirection. Another level of indirection is an abstraction. Examples of indirection are something as simple as assigning a variable a name, a pointer, creating a function, object containers, APIs. Most of the benefits that we see, all the layers that we see in computer programming, each of those is piling one level of indirection on another. Dry is a good principle. It encourages single responsibility constructs like functions and subroutines or methods to implement reusable code. It's not a it's not a wrong abstraction to have a square root function. It's not a wrong abstraction to have a read function. Those things make sense. In my world, my characterization has been computer programming is about naming things and subroutines. But I want to show you very quickly one of the rabbit trails that I ran down working with some code fairly recently. This is from, I have a blog at joepython.com called Programming in Public. And the blog itself is made of static web pages, which I create using Flask and an add-on to Flask called Frozen Flask. The example is a couple of very similar functions. These are just 2 pages on the website, the index page and the about page, and you can see that they're very nearly the same. Before I get into the details of drawing this out, I want to finish Wheeler's quote. All problems in computer science can be solved by using another level of indirection, but that will usually create another problem. Those of you who have worked with regular expressions are probably familiar with the warning. You have a problem and you decide to use regular expressions to solve it. Now you have 2 problems. This is an example in which immediate or automatic or formulaic application of the dry principle can get you into real trouble. So, we have, I'm sorry, where are we? We have the 2 programs that I mentioned, and then there was a third. It's not quite the same thing, but these are all just very simple web pages, have very relatively fixed information on them. And so I decided to put them all together. And by the time I had dried everything out, this is what it looked like. And what you have here, I'm going to use my pointer. What you have here, oh yeah, that helps a lot, is that because these things don't really belong together, I've had to create a bunch of parameter values or a bunch of working values in order to use them at the same time. So, whoops, wrong. Wow, how far did it? Anyway, I have to use them all at the same time. And the code that was common that I wanted to reduce in the original 2 functions is now reduced to, where is it? Here, okay? That duplicated code, I don't need to dry it out anymore because I've reduced all this to one function. Well, it turns out this was a really bad idea. I worked it all the way through. There are multiple levels of dry, all the way back through the model, all the way to the database, and some of it worked out just fine. But this is a nearly perfect match to the scenario that Sandy Metz lays out in her wrong abstraction post, and she calls it a sunk cost fallacy. Resolution to all of this is based on the considered and tested application of appropriate principles, that is, on necessity. So first, I take out that 3rd function that I didn't need, and then it turned out that my setup, the application that I was depending on in the Frozen Flask none of the top level stuff dried out. So I wound up with 3 functions. I started with 3 functions. They did wind up with, be careful, a lot of drying here and here, where things were able to consolidate in the background, but in the foreground, very little of it dried up. This is connected to other things that were discussed earlier today. The indirection increases complexity. So we think that we're simplifying a program, we think that we're simplifying a process, but we're adding to the complexity of the application. So, a couple of statements here. Such as modern computing. Everything simple is made too complicated because it's easy to fiddle with. We have a plastic medium. Everything complicated stays complicated because it's too hard to fix. Simplicity is a prerequisite for reliability. I like this one. Layers are for cakes, not for software. The central enemy of reliability is complexity. So, the problem with all of this, the unexpected consequence of working in computer software in IT is that we appear to the world to be cutting edge guys, bleeding edge technology, and yet you walk one of us into a room with servers running old COBOL programs, and nobody wants to touch it. Because once you have a piece of software that works, nobody wants to fiddle with it. It's too scary. We don't have the information that we had when we built the software in order to confirm that changes we put into it won't break something else down the line. So what do we do when we're faced with these types of problems? Very simple solution. When in doubt, do what I did. Do the right thing. And when the right thing turns out to be wrong, you walk it back. Chalk it up to experience, and your next decision will be better. But I repeat myself. Good decisions come from experience, and experience, as I said earlier, comes from bad decisions. All right. The website, the example of the compressed code, the dried code, the experience of drying it out and turning out that it wouldn't work, is at the joepython.com site. I didn't mention actually the link there. There are multiple threads. Go to the blocks thread, and under that there's a post called Dry Rot. And that's the post that will explain the details of how all that software was used and misused in the process. Majority of the programming quotes in this talk came from a site called deafprogramming.com. I recommend it. It's very entertaining. I'd like for you to check out the Joe Python site. It's a very peculiar place. I'm developing a blog, and I am blogging about the process of writing blogging software. Everything is public. It's excruciatingly detailed, and I hope that you can enjoy it. Thank you.